Okay, so now this topic right here is topic number 6, finding the arc length or the equation of the arc length. I guess I asked the professor if we just needed the equation, and he said we could uh, calculate it actually if we are able to. And it's sounding to me like it's not going to be very hard. But in any case, we're going to find T, N, B, AT, and AN, right? So before we redefine those variables right there, we're going to recall that the arc length formula is this right here. And then this portion of the arc length is the magnitude of r prime of t. So we rewrite that formula basically as just that, right? And we're going to use that formula to find the arc length. Very easy. You just put it in your cheat sheet and then you should be good. We're going to work out this example right here. Well, I guess you could work it out on your own because it's very, very straightforward. You're just plugging in stuff, right? Now we're up to reviewing this one. So, some terminology review that I kind of had to look for in my notes because I haven't touched this in a really long time. We got our T, our capital T over there. That's our unit tangent vector. So that's the tangent vector with the magnitude of 1, right? And that's this right here. So that's the only, this right here is the only equation for this unit tangent vector. So you can remember that. You can put it on your formula sheet. There, done. And then you have n, which is the principal normal vector. And it's this right here. But you also have n, which is exactly the same thing, principal normal vector. But you have this equation. And note that we're using this equation when t is constant. So meaning when t is like sine squared plus cosine squared, which is 1. When t is easy, when t is not very full of like square roots and stuff, something that you could derive, something that you could work with because you're going to have to do that, right? But if you can't, then you use this equation right here. All right, so we have our b, the binormal vector, and that's just the cross product of t and n. And next we have the curvature, which we also have two formulas for. So when t is constant, or when r is constant, right, we're going to use this equation right here. That's a very easy equation to use, especially when you've already found your r prime, your magnitude of r prime, and your magnitude of t prime over there. You just plug it all in, okay? But if you can't, then you use this. This is when t is messy, right? Okay, and then a of t, that's the tangential component. A of n, that's the normal component. They're kind of easy to remember. It could be a little confusing, but that's what we have a formula sheet for. Okay, so we're going to work out this example right here. Given r of t equals 2 cosine t, 2 sine t, find t, n, b, k, a, t, a, n, right? So we're going to do this one first. And this was in this order, by the way. I haven't done an example that was in this order because of just how tedious this whole topic is. It's a lot of different ways that you could ask this question. So we're going to work on this one first. All right, so we find t, and we got our equation right there. That's just a bunch of plugging in. So the derivative of r is just that. The derivative of this is just that. And then we're plugging that in, and we're getting this. Definitely take a look at it because they're all pretty straightforward. Like I said, a lot of plugging in, and if something's not clear, and I'm always here to help. Okay. And then same with this right here. And when you do all these things, right, you could find, when you do both those things, you could find these things very quick and easy. Okay, so you got your b there, and here you can see that I literally just plugged in 1 over 2 because I already got my value for this. I already got my value for this. So I went back to my answers and then I plugged it in, right? So same with this, just a bunch of plugging in. Same with this. And we're done with that. But like I said, I haven't done any more problems. I'll probably do some tomorrow. But yeah, that's as far as we know about this. I hope that was not too difficult.